Good morning, dear students. How are you all? Today I brought the revision lecture of the Unit 2, that is chemical bonding. In this lecture, we are covering following topics: the introduction of the chemical bonding, the energy changes in the bond formation, the valence bond theory, which explains the covalent bond formation. What are the features of the valence bond theory? Various types of the overlapping and limitations of the VBT means valence bond theory. What is the learning outcome of this lecture? The students will able to understand about the chemical bonding, the energy changes in the bond formation, the valence bond theory, explanation of the bond formation, the features of the theory, the types of the overlapping, as well as the limitations of the VBT. Lewis in 1916 suggested that the sharing of the valence electron between the two atoms forms the covalent bond, and the pair of the electron is counted in both the atoms. For example, if we see the hydrogen molecule, the hydrogen atom is having one electron and the another hydrogen atom is also having one electron. If they both share their electron, it becomes two, which attain the electronic configuration of the noble gas helium and attain the stability. Here also you can able to see the sharing of the electrons by the two hydrogen atom forming the hydrogen molecule. By this method, both the atom goes for attaining the electronic configuration of the noble gases, which is responsible for their stability. But the formation of the strong bond between the two atoms by sharing of the electrons could not be explained at all in terms of all the classical mechanics we have studied before in the atomic structure. So how the covalent bond is strong enough only by sharing the electrons? It can't be explained by any of the theory in the classical mechanics. However, on the basis of the quantum mechanics or the wave mechanics, two approaches were developed to understand and explain the covalent bonding, means the sharing of the electron. So the two approaches in the quantum mechanics has the success for the explanation of the covalent bonding, and they are the VBT, valence bond theory, or we can say the atomic orbital theory, which was put forward by the Hitler and the London in 1927 and further developed by the Pauling and the Slater, means the modification done by the Pauling and Slater, and it is one of the famous theory for the explanation of the covalent bonding having the quantum approach. The second most important theory for explanation of the covalent bonding is the molecular orbital theory, which was developed by Hund and Mulliken, Huckel and others in 1932. So these two theories are the main theories for the explanation of the covalent bond formation in the molecule and how the strength of the covalent bond is strong. Now we see the energy changes in the covalent bond formation. The formation of the chemical bond is possible only if the approach of the atom is accompanied by the decrease in the energy. When the two atoms come close to one another, it goes for decreasing their energy by sharing of the electrons, by exchanging of the electron. So this is a very important approach of the atom, which goes with the energy decrease. So in the hydrogen molecule, when Ha, that is the atomic orbital of one of the hydrogen atom, and Hb is the another atomic orbital of the hydrogen atom, come close to one another, the various attractive and the repulsive force act on it. The attraction of the electron of the one orbital to the nucleus of the another orbital causes the attractive forces. Similarly, the electron of the Hb orbital having the attraction of the nucleus to the Ha orbital goes for acting the attractive forces. There are also the repulsive forces which act on it, that is between the nucleus of the two orbitals, that is Ha nucleus to the Hb nucleus causes the repulsive force, as well as the electron of the Ha and the electron of the Hb causes the repulsive forces. So when they come close to one another, the attractive force becomes dominant over the repulsive force. At that distance, it goes for minimizing the energy and the bond formation takes place. So here in this, there the same thing is observation is there. The nucleus is having the attraction with the electron. Here you can able to see in the another diagram, as well as the repulsive forces acting between the similar charges. So when the attractive forces goes on dominating, it forms the bond. When any of the two atoms come close to each other, we have seen in the diagram, the new forces of the attraction and the repulsion set in, and the forces are due to the nucleus of one of the atom. We have seen the Ha to the electron of the another atom, that is Hb, is the attractive forces, as well as the vice versa. If net result is the attraction, the energy goes on decreasing and the bonding takes place. So at a certain minimum distance, this attraction force goes on dominating, and there the bonding takes place. On the other hand, if net result is the repulsion, the energy goes on increasing and the bonding does not take place. Understood? If the repulsion force increases or repulsion force dominates the attraction force, so the bonding doesn't take place and energy goes on increasing. And if the attractive forces become dominant, then the bond formation takes place and the energy minimizes. So that's how the approach of coming together causes the energy decreases. The decrease in the energy can also be understood in this graph. We have plotted on the y-axis, that is the potential energy, that is the stored energy in the atom. So here on the x-axis, we are seeing the distance, means when they come closer to one another. So as we see, the two atoms come close to one another, the distance goes on decreasing, so the energy goes on decreasing likewise. So it goes on decreasing the energy at a certain minimum distance. Understood? So here come with the point with a certain minimum energy. So that is the point where we have the minimum energy. It goes on decreasing the energy with the distance coming to close to one another, and at this distance the minimum energy is there in the orbitals, and if it comes more close to one another, if the distance increases from that, so the energy goes on increasing. Here you can able to see in the graph, the energy goes on increasing. Means this is only the point at the minimum distance. It causes that minimum energy, and at this distance only the bond formation takes place. And this distance between the two atomic orbital is called bond length. If we see the bond length of the hydrogen molecule, two hydrogen atom comes together, that the bond distance of the hydrogen molecule for the covalent bond formation is 0.74 Armstrong. It is the bond length and bond distance of the hydrogen molecule. So that's the important thing of the bond formation, to understand how the energy goes on minimizing at a certain distance. If that distance increases more close to one another, at that appropriate distance only the bond formation takes place. So the minimum distance between the nuclei of the two atoms constituting that chemical bond is called bond length. So the bond length of the hydrogen molecule is 0.74 Armstrong. And the certain amount of the energy is released during the formation of the covalent bond. As the energy goes on releasing and minimizing the energy, so we can say during the bond formation a certain amount of the energy is released, or during the formation of a chemical bond. More is the amount of the energy, stronger the amount. We can understand the bond strength, means how your bond is stronger. It depends on the energy release. Greater the energy released during the bond formation, stronger will be the bond. And we can say its reverse also. If we want to dissociate the bond, the same bond, that amount of the energy required, that is called bond dissociation energy. So we can say the energy released during the bond formation is equivalent to the energy required to break it. Understood? So that is called the bond energy. And it is also, if we are saying to break it, that is also said to be bond dissociation energy. The two theories which is used to explain the covalent bond formation as the minimizing the energy, the first theory was valence bond theory, and it was put forward by the Hitler and London in 1927 to explain the stability of the covalent bonded hydrogen molecule, and also equally applicable to other covalent molecules containing two or more than two same or different atoms. And this is the acceptable theory for the explanation of the bond formation of the hydrogen molecule, or the molecule having two or more than two same or the different atom. So let's see what are the features and the postulates of the theory so that the covalent bond formation can be understood. The first feature is, for the formation of the stable covalent molecules, the atomic orbital of one atom overlaps the atomic orbital of the other atom. Means this theory say that the electron, the valence electron, go for participating in the bond formation, and it go for overlapping with the another orbital, so that the electron density will be larger between the two nuclei, and this causes the decrease in the nuclear repulsion. When the electron density becomes higher between the two nuclei, it causes the decrease in the repulsion and increase in the attractive force. As there increase in the attractive force means the energy goes on decreasing, and there the concentrated electron cloud forms, which is only known as covalent bond. So this how VBT explained the covalent bond formation. It says that the atomic orbital of one of the atom in which the valence electron goes on overlapping with the another orbital having the concentrated electron density between the two nuclei, which decreases the repulsive forces, nuclear repulsion, and the increases the attraction, so that it goes for minimizing the energy and the bond formation takes place. The concentrated electron cloud between the nuclei only called covalent bond. And the strength of the covalent bond depend on the extent of the overlapping. How much extent of the orbitals goes on overlapping, the strength depends on that. If it is greater, means stronger bond formed between the two combining atoms. And this is the important thing, how it explains the strength of the covalent bond. It depends on the extent of overlapping. Greater the extent of overlapping, stronger the bond between the two combining atoms. Each of the overlapping orbital should contain at least one unpaired electron. This is again an important feature of the VBT, means the overlapping orbital should contain at least one unpaired electron with the opposite spin, so that when it forms the bond with the another orbital, the electron get paired, and the neutralization contribute the stability of the bond. So if one of the orbital is having the unpaired electron like clockwise spin, the another orbital is having the anti-clockwise spin, and when the bond formation takes place, it get neutralized. So this is main responsible for the stability of the bond. Greater overlapping shortens the distance between the nuclei. If the two orbitals go on with the greater overlapping, so the distance between the two nuclei, it goes on having shorter, and shorter the bond length. If the bond length is shorter, means the stronger bond it is. This is the meaning. This is how the strength would be understand in the VBT theory. So shorter bond length goes for giving us the stronger bond. Number of half-filled orbitals in an element is called its valency. So mainly the valence electron go on participating in the bond formation, VBT says, and rest of the electrons remain the same, or the identity remain the same. The rest inner electron, we can say. The inner electrons in the orbitals, in the atomic orbitals, do not participate. It remains the same. Only the valence electron goes on participating in the bond formation. Overlapping of the orbitals causes the release in energy. When they go for overlapping, it releases the energy, it minimizes the energy, and the bond formation takes place. The electron taking part in the formation of the covalent bond is having almost equal energy. So the electron or the valence electron, we are saying that participate in the covalent bond formation, means their energy should be almost equal, VBT says. The amount of the energy released per mole at the time of overlapping is called bond energy. We have seen in the graph also the energy released when the bond formation takes place, or it can be said the amount of the energy released per mole at the time of the overlapping is called bond energy, and that is also known as stabilization energy. Understood? How if it is very higher, the stronger bond it is. If the bond energy is higher, strong bond it is, and highly stable molecule it is. We can easily understand by the bond energy. If the same molecule can be represented by the number of resonating structures, means it is stabilized by the resonating structures, like we know that benzene is stabilized by the 5 resonating structures. Then the molecule is further stabilized. If it is having more number of the structures to stabilize it, so their energy is also higher and their stabilization is also higher. VBT says. VBT says that atomic orbitals undergo overlapping, and which is responsible for the bond formation. So let's see the various orbital overlapping in the schematic representation of the overlapping. The first is between s orbital. S overlapping it is. It is also called the head-to-head overlapping. It can be seen in the hydrogen molecule. We have taken the example of the hydrogen molecule because the S, it is having one electron which goes in the s orbital, which is spherical shape. So the s orbital of one of the hydrogen atom overlap with the another hydrogen atom, undergoes this S overlapping, which goes with the head-to-head overlapping, and the bond form along the internuclear axis, and this kind of the overlapping is also called symmetrical overlapping, and very strong covalent bond is formed in this overlapping, which is called sigma bond. So always when a symmetrical overlapping takes place, the bond is formed between the internuclear axis, and that is the stronger bond. Covalent bond is formed by the head-to-head overlapping, by the symmetrical overlapping, and the bond formed along the internuclear axis, that is sigma bond. Here also you can able to see the s atomic orbital goes with the overlapping with this sigma bond, that is the internuclear axis. This is the bond axis here. This is also the bond axis here. So along the internuclear axis, the bond is forming this concentrated cloud between the nucleus. The second type of the overlapping is between the s to p orbital, which can be shown in HCl, because H is having the s orbital and the p orbital of the chlorine atom. So here it is showing that s orbital of the H atom and the p orbital of the chlorine atom undergoes again the head-to-head overlapping. This is the symmetrical way along the internuclear axis. Again it is formed the bond along the internuclear axis. The strong bond is formed, which is the sigma bond. So the sp overlapping is also head-to-head overlapping, and in this the sigma bond is formed. The next type of the overlapping can be seen in the molecule is in between the p orbitals. the atomic orbital, one atomic orbital of the p to the another atomic orbital of the p, how it can takes place. It can be shown in the chlorine molecule and fluorine molecule, in which the p orbitals go with the overlapping. So the pp overlapping can be divided into two types, and it can be uh, having the two types of the overlapping with the bond formation. The first is coaxial overlapping. It is the symmetrical overlapping when the p goes with the symmetrical way. Here you can able to see the p orbital of the one atom goes in a symmetrical overlapping to the p orbital of the another atom, and this is also an example of the head-to-head overlapping, and in this also the strong bond is formed along the internuclear axis, that is sigma bond. So when it goes with the symmetrical way, it forms the strong bond, sigma bond. The another type of the overlapping in the PP, it is the sidewise overlapping, which is asymmetrical way, which is shown in oxygen molecule, nitrogen molecule. So sidewise overlapping is not the strong overlapping, and this how the p orbital of the one atom undergoes with the p orbital to the another atom. Sidewise it goes with the overlapping when come close to another, and the electron density is above the internuclear axis, above and below. So it lies above and below to the axis, and this kind of the bond formation by the sidewise overlapping is called the pi bond. So here also you are able to see the above and below to the internuclear axis we have the electron density, and this type of the bond is called pi bond, and it always the pi bond formed along with the sigma bond. Understood? It doesn't forms alone, it forms with the sigma bond. So as we have seen the various features, how it explains the covalent bonding, the VBT features, it says that the atomic orbitals come close to one another or goes with the overlapping, and overlapping can be head-to-head overlapping or the sidewise overlapping, and it forms the concentrated electron cloud between the axes and forming the bond. So there are certain limitations of the theory which can be easily understood here. The first limitation come up, it satisfactorily explain the formation and the shapes of the simple molecules, as VBT has the success to explain the hydrogen molecule and the molecule which is having the two or kind of the same or the different atoms. It can easily explain by VBT, but it fails to explain the shape and the geometry of the complex molecules having more than 3, 5 electrons. It failed to explain the odd electron molecules or ions. It cannot give the explanation of the number of electron which is having odd number or the ions. For example, here the H2 plus, which is if we talk about the ionic species, H2 plus means one electron goes, only one is left, where no pairing of the electron takes place. How it exists in the nature. So that is become the limitation of the VBT. It doesn't explain the odd electron molecule bonding or the ions. The third limitation is no light is thrown on the coordinate bonding when the atom goes of sharing both the electron, because in the coordinate bonding only one atom share their both electron. In the covalent, one each of the atom goes with the sharing, but in coordinate only one atom goes with the sharing. So nothing explanation come up the sharing of the electrons such like that, or the coordinate bonding found in the molecule. It doesn't explain by the VBT. Another important limitation come up here. It failed to explain the paramagnetic behavior of the oxygen atom. If according to the VBT we see and it is forming the bond likewise to the overlapping, why it's showing the paramagnetic behavior if we say it's all the electron get paired by sharing? So if it is paired, it should be of diamagnetic nature. According to the VBT, oxygen should be the diamagnetic nature, because if it is a valence electron goes on participating, so the electron get paired by the overlapping. So diamagnetic behavior should exist in oxygen, but it doesn't have the diamagnetic behavior. It has the paramagnetic behavior, which become a limitation. After the bond formation, the atoms retain their identity and the identity of the atom is not lost, which is proven wrong afterwards when the molecular orbital theory come up. So we can say the identity of the atom is not lost according to the VBT, which is not seen in the next theory. Molecular orbital theory say a new identity always formed when the bond formation takes place. So this is also the limitation of the VBT. So this we have seen the VBT theory come up for the explanation of the covalent bond. In the next lecture, we should take the concept of hybridization, by which we can understand the various existing molecules and the geometry. So till then, thank you and take care.